Hello students, welcome in my YouTube channel Chemistry by Shivam Education. Myself Gangani sir. Now today I will discuss with you chemical and physical property of cyanide compound. So let's start. Now cyanide, we know that when cyano group is attached with a alkyl or aryl ring, then this compound is known as a cyanide compound. Okay. Now when cyanide hydrolysis is done in acidic medium by using a water. When hydrolysis is done in aqueous solutions, then at least 2 mole of water molecule is required. Now this nitrogen will remove in the form of ammonia, and this cyanide group will convert it into carboxylic acid. So very simple thing on hydrolysis of cyanide compound. Hydrolysis of cyanide compound gives carboxylic acid, and with this we are getting ammonia as a byproduct. Now whatever carboxylic acid obtained in next step in the presence of acid, suppose it allowed to react with an alcohol. When it allowed to react with alcohol, we have already studied esterification process. Now from carboxylic acid, hydroxyl group will remove, and from alcohol, H will remove. This both molecule remove in the form of water, and we get ester. So it is observed that from carboxylic acid we can prepare ester. So directly when both step carried out, hydrolysis is done in the presence of acidic medium and alcohol is also added into it, then directly in one step we will get a ester. So very easy things. Hydrolysis of cyanide gives carboxylic acid, which on esterification, this process is known as a esterification. So by using this esterification process, we will get a ester. Now, little different thing. Whatever cyanide compound we have, हमारे पास जो cyanide compound है, now we are doing reduction of this in the presence of lithium aluminium hydride. So on reduction, this both pi bond will break. Pi bond is easily break. Now 2 hydrogen will be added on carbon and 2 hydrogen will be added on nitrogen. So by reduction of cyanide compound, we will get a primary amine. Now whatever amine obtained to us, it has the same number of carbon present in a cyanide compound. So now these are the 2 easy chemical property of cyanide compound. Now, next thing, reaction of cyanide compound. Now, cyanide compound is easily react with this different type of Grignard reagent. Suppose we have this cyanide compound RC triple bond N. Now, this cyanide compound is allowed to react with a Grignard reagent, and as a Grignard reagent I have taken alkyl magnesium bromide. So this alkyl magnesium bromide is taken by us. Now it is observed that reaction occurs in this way. This cyano group is polar group, nitrogen has a partially negative charge and carbon has a partially positive charge. So it is observed that this carbon nitrogen pi bond will break, alkyl will be added on carbon, and nitrogen give its electron to magnesium. So as a result, we will get this type of intermediate product, RC double bond N MgBr. Now R dash is added on carbon. Now whatever product obtained, it is considered or known as an intermediate product. So we have obtained this intermediate product. Now whatever intermediate product is obtained us, this will undergo hydrolysis in the presence of acid. Now suppose in the presence of acid, when we have carried out hydrolysis, then hydrogen will be added on nitrogen and oxygen will be added on carbon. So when hydrolysis done by us, we will get a RC double bond OR dash and we will get NH2 MgBr. Now whatever main product obtained to us, it possesses carbonyl group, so it is known as a ketone. So from cyanide compound one can prepare acid, ester, amine as well as ketone is possible to prepare. Now let's see different type of example of this type of structure. Suppose I have taken as a cyanide. Now first example we will discuss. Suppose as a cyanide I have taken this cyanide, name of the cyanide you are knowing very well. This is nothing but methyl cyanide. Now this methyl cyanide is allowed to react with Grignard reagent methyl magnesium bromide. So when reaction occur, we know very well this alkyl group will be added on carbon, this pi bond will break, it electron will go on nitrogen, and nitrogen donate electron pair to magnesium. So now we will get this type of structure, CH3 C double bond N, MgBr, and methyl group is added on carbon. Now whatever structure obtained to us, now it undergo hydrolysis. When hydrolysis is carried out in the presence of acid is same as we will get a ketone. This double bond will break, oxygen will be added on oxygen will be added on carbon and hydrogen will be added on nitrogen. So now whatever structure obtained CH3 C double bond O CH3. What is name of this structure? Yes, exactly, it is known as a acetone, and this will be byproduct, same thing, no any change, NH2 MgBr. With magnesium both this thing is attached. So by using this method, suppose we want to prepare 2-butanone, then what we have to do? We have either two different ways, either we can take here ethyl or either here we can take ethyl cyanide. Suppose I have taken same structure, no any change, methyl cyanide is taken by me. It allowed to react with the ethyl magnesium bromide. Then what will be product of our structure intermediate? Now you are knowing very well this alkyl group will be added on carbon, pi bond break, nitrogen donate electron pair to magnesium. So now as a result we will get this type of structure CH2 CH3. Now here carbon having a double bond with nitrogen and MgBr. So this type of intermediate product will be obtained to us. Now whatever intermediate product obtained, it undergo hydrolysis in the presence of acid. Now during hydrolysis process this carbon nitrogen bond will break. Oxygen will be added on carbon and this both hydrogen will be added on nitrogen. So whatever structure obtained to us, it has a ketone group on second carbon. Now byproduct will be same as, no any change. Now this time I am writing in little different way, MgNH2Br. Same thing. Now whatever structure obtained to us, it is given name as a 4 carbon in long chain, so it is a 4 carbon. So name of this structure butane 2-on. So 2-butanone can be prepared by using methyl cyanide. So we will discuss example number 2 also. Now just I am giving you example number 3. Pause your mobile or laptop and try to solve what will be the product. Suppose I have taken ethyl cyanide. Here I have taken a ethyl cyanide. Now this ethyl cyanide is allowed to react with the ethyl magnesium bromide. Now we have to predict what will be obtained as a product. Try to solve it. Okay. I hope you did well. Now here this ethyl group will be added on carbon of cyanide. Now nitrogen, carbon nitrogen bond we are giving separately, pi bond will break and nitrogen donate electron pair to magnesium as it is same method, no any change. Okay, now ethyl is added on this carbon. So now it has a long chain containing 5 carbon. Now same method hydrolysis done by us. When we are doing hydrolysis in the presence of acid, no any change. Oxygen will be added on carbon, hydrogen will be added on nitrogen. So hydrolysis of this we will get a 5 carbon containing species and it has a name 5 carbon, so pentane 3-on. So we can write this 3-pentanone also. 3-pentanone is obtained to us and byproduct will be common. So in this part we have discussed that When cyanide compound is allowed to react with Grignard reagent, it gives us intermediate product. Whatever intermediate product obtained to us, it on hydrolysis gives us a ketone. So by using this method, so if we have taken methyl cyanide and allowed to react with methyl magnesium bromide, then via intermediate our main product will be acetone. Or acetone is also known as a 3-propanone. So in different type of exam, you are given these two compound and you have to write what is the final product. So here we have discussed that methyl cyanide on reaction with ethyl magnesium bromide gives us intermediate, which on hydrolysis gives us a butanone. Similarly, in third example we will discuss ethyl cyanide on reaction with the Grignard reagent ethyl magnesium bromide. We are getting this intermediate product, which on hydrolysis gives us 3-pentanone. So propanone, butanone, 3-pentanone, etc. is possible to prepare by using this method. Now we discuss example based on this first two property. Now we have discussed this thing that cyanide on hydrolysis gives us acid and byproduct will be ammonia, which on further reaction with the alcohol produce a ester. So now suppose I am giving you problem sum or example based on this. Suppose I have taken acetonitrile. This structure is known as acetonitrile, or IUPAC name of acetonitrile is nothing but ethane nitrile. Now this ethane nitrile directly hydrolysis done in the presence of acid. Suppose hydrolysis done in the presence of acid, we will get a 2 carbon containing carboxylic acid, which is known as a acetic acid. Now whatever acetic acid obtained to us, suppose it allowed to react with the methanol in the presence of acid, then this reaction is known as a esterification. Now by using this esterification process, here hydroxyl group from acid and hydrogen from alcohol remove in the form of water molecule, and as a result we will get the structure which is known as a methyl acetate. So methyl acetate is possible to prepare by using this method. Now directly you have to write what will be the final product of our example number 2. Suppose I have taken a propane nitrile, and now this propane nitrile, whatever structure obtained to us, this is nothing but a propane nitrile. Now propane nitrile, two things we are doing. First we are doing hydrolysis in the presence of acid, and second whatever product obtained to us, it allowed to react with the ethanol in acidic medium. Then what will be the final product of our structure? This you have to write. Now 1 minute time is given to you, try to solve. Then if you are knowing the step, easily you can do it. First hydrolysis of propane nitrile gives a propanoic acid, and propanoic acid on esterification gives ethyl propanoid. So the structure of final product A, we can write this is nothing but ethyl propanoid. So this ethyl propanoid will be obtained to us. Now similarly, reduction property related question. Suppose we are given this compound benzonitrile. Now you are knowing very well what is the name of this structure. This is nothing but a benzonitrile. Now this benzonitrile reduction is carried out by using lithium aluminium hydride. Then lithium aluminium hydride is strong reducing agent. Reduction can be done. 1 mole of hydrogen gas will be used. Sorry, not 1 mole, but 2 more hydrogen gas will be used. This carbon nitrogen triple bond will break. 2 hydrogen added on carbon, 2 hydrogen will be added on nitrogen. So now what is the product of our reduction reaction? Then we can write benzene ring having a CH2 and H2. And you know that what is the name of this compound? It is known as a benzyl amine. So now we have discussed this two reduction property. When acetonitrile hydrolysis is done, it gives acid, which on reaction with the alcohol, it gives ester. Now, variety of example. In a competitive exams, you have to ask sometimes both step given directly. If you know very well each and everything, then final product you can write and correct selection done by you. Here we have studied cyanide or reduction gives a amine. Now we have to discuss what are the physical property of amine. Now we have to discuss what are the different type of physical property of cyanide compound. It is observed that whatever cyanide compound we are taking, this cyanide compound are polar in nature. When we take cyanide, then cyano group is present in organic compound. This nitrogen has more electronegativity, so it has a partial negative charge, and carbon has a partially positive charge. So we can say that cyanide compound are weak polar in nature. Now, this compound weak polar in nature as well as this compound are working as a weak basic. Something is observed that whatever cyanide compound we have, this cyanide is actually non-toxic in nature. Cyanide are non-toxic. This sometime in our mind we have said that cyanide are toxic in nature, but actually isocyanide is highly toxic. So we have to write that cyanide are non-toxic in nature and cyanide compound are sparingly soluble in water. So in water their solubility will be less. Particularly more carbon containing cyanides are less soluble in water, but we can write this thing also that less carbon containing cyanide are water soluble. When number of carbon atom increase, their solubility in water will decrease. So we have observed that in cyanide compound there is no possibility of intermolecular hydrogen bond. So we can write that intermolecular hydrogen bond. This type of intermolecular hydrogen bond is not possible in cyanide. They are polar, but then after not possible in cyanide. So now here intermolecular hydrogen bond is not possible in cyanide compound. So when we compare cyanide compound with the carboxylic acid having the same number of carbon atom, suppose we have taken an acetonitrile, or this compound is known as a ethane nitrile. Ethane nitrile is IUPAC, name of cyanide compound. So now when we take 2 carbon containing acid, then it is acetic acid, or we can write it IUPAC name ethanoic acid. So now ethane nitrile, it is observed that boiling point of ethane nitrile is 355 Kelvin, while acetic acid it has a 391 Kelvin. In acetic acid, because of carboxyl group or hydroxyl group present in carboxylic acid can form hydrogen bond. So it is observed that because of formation of hydrogen bond, melting point and boiling point of carboxylic acid is higher, or we can write in this way also, boiling point and melting point of cyanide is always lower than that of carboxylic acid. Similarly, suppose we have 3 carbon containing propane nitrile. This is nothing but a propane nitrile. Now whatever propane nitrile we have, it will be in a liquid state or it has a boiling point 370 Kelvin. Now, when it compare with the same carbon containing carboxylic acid, which is propanoic acid. So now it is observed that in propanoic acid, because of the formation of hydrogen bond, it has a boiling point 414 Kelvin, while propanoic acid having 370 Kelvin. So we can write this thing. In cyanide compound, intermolecular hydrogen bond is not possible, which is possible in a acid, carboxylic acid. So boiling point of cyanide is always lower as compared to corresponding carboxylic acid. We have observed already that cyanide are non-toxic, they are weak basic in nature, they are polar, and many organic compound is possible to dissolve in it, particularly this acetonitrile. So for acetonitrile we can say that acetonitrile is highly polar in nature. Whatever compound we have, this is highly polar. This compound is highly polar in nature. Therefore, it is observed that many organic compound will be soluble. Many, we can write OC. What is meant by OC? Organic compound. So in acetonitrile, many organic compound is soluble. Easily we can dissolve in it. Second thing, it is observed that whatever acetonitrile we have, once again common name of this structure is acetonitrile. This acetonitrile having a low molecular mass, it is highly polar in nature, it has a many organic compound is soluble into acetonitrile, and it is observed that it has a low boiling point. So it can be removed very easily. Because of all this reason, we can say that acetonitrile is useful as a solvent. We can write this thing, it is useful as a solvent to dissolve many organic compound. So out of all this cyanide compound, particularly acetonitrile is very high polar in nature, or we can say highly polar in nature. Many organic compound is soluble into it, and it has a low boiling point. And one more thing, it is inert in nature. So it is never reacting with the solute when it is used as a solvent. So because of all this property, acetonitrile can be used as a solvent, while cyanide compound is used to obtain many other functional group. Either we can obtain acid, ester, amine, or we can obtain ketone with the help of cyanide. So students, if you like my lecture, then please don't forget to subscribe, to share with your friends. See you in next lecture.